Today's lesson is about dividing monomials, and so we are continuing with our exponents and radicals, Unit 6, Day 3. We have just learned in the previous video that we can write a division problem, a quotient of powers, as keep the base, and we say m minus n is our quotient of powers rule, and then we learned power of a quotient. We get to distribute that outer exponent to any exponents inside the parentheses. And so remember that this is x to the 1 and y to the 1. So I'm now going to have x to the 1 times m over y to the 1 times m. And so that's my rule that I'm going to follow. In our previous videos, we did the first two examples here. So we are going to start with this example right here. I'm going to distribute that -2 exponent to each of the exponents inside. So I have a to the 3 times -2 is -6, and I have b to the 2 times -2 is -4. And of course that really equals b to the 4th over a to the 6th. And I'm going to pause here and not really do expanded form, but I want to show you a shortcut that you can use when you have a negative exponent outside of a fraction. You can take the reciprocal of that fraction that's in the parentheses. We're going to flip it upside down, and if I flip it upside down, I get to change my outer exponent and make it positive. And so instead of expanded form, I'm just going to prove this to you. We end up with b squared to the power of 2. We end up with b to the 4th all over a to the 3 times 2 is 6. Okay, your final answer is b to the 4th over a to the 6th. Okay, so we're going to use all of our rules here when we're dividing with monomials. And so I'm going to distribute this outer exponent to the inner exponents. Even if I can't see them, I'm still going to have to distribute. So this is going to be 2 squared over 3 squared, which equals 4 over 9. Okay, number 2, I'll try to go in the correct order here. I'm going to actually rewrite this. I'm going to rewrite this as -3 over y. We all know that that's the same information. It's just going to be a little bit easier to make sense of when I'm multiplying things. Okay, if I distribute this outer exponent, 3, it's going to this -3 in the numerator. -3 times -3 is 9, times -3 is -27. That's my numerator. And the exponent has to go to that bottom y, so it's going to be y to the 3rd. Okay, I have 2 different ways right off the bat that I can think about this. I can flip it upside down and make my exponent positive, or I'm just going to keep using our rule that says we distribute that outer exponent. So this is going to be a to the -3 over b to the -3, and I want to move those guys around and make them all positive. So I have b to the 3rd over a to the 3rd. Okay. When you have a problem like this one, w squared over w, if you can simplify inside there first, go for it. But you don't have to. You can also distribute that outer exponent to everything and then simplify. I'm going to simplify first, so I know w squared over w is just w, right? W to the 2 minus 1 is w to the 1, and that is all to the -1 power, which means that I just need to relocate it, and it's going to be 1 over w as the answer. If you try doing this several other ways, you should always get 1 over w as your answer. All right, I have a to the 9th over a to the 5th inside those parentheses. It's all to the -1 power. I am going to simplify inside first again. I have a to the 9 minus 5, which is 4, and that is all raised to the power of -1. So I can look at this way, a to the -4, and it's going to equal 1 over a to the 4th. Again, there are several ways that you could look at this. All right, I definitely want to simplify in here first. So listen closely as I talk about how I am doing this. I'm going to simplify first. So I know that -6 over 2 is -3, right? Those guys are done. X squared over x, I know, is just going to be x in the numerator, right? That's x to the 2 minus 1. I have y in the numerator and I have y to the third in the denominator. So this is a different way to think about this that I haven't really talked about. I'm going to take the difference of these exponents. I have an exponent of 1 and I have an exponent of 3. I'm going to say 3 minus 1 is 2. But I'm going to keep my answer wherever the bigger exponent was. So if 3 minus 1 is 2, I'm going to say y squared stays in the denominator. I have already taken care of those x's. It stays in the denominator because that's where my bigger exponent was. Okay, so I'm also going to show you if I had y to the 1, just this little part of it, right? If I had y to the 1 over y to the 3, you know that equals y to the 1 minus 3, so it equals y to the negative 2. And of course we want that to be 1 over y squared. So that's the other way to look at how I ended up with my y squared in the denominator. Okay, now I need to distribute that outer exponent to everything inside. So this, in my mind, equals, I am going to hit my, you can't see it, but I'm going to have to write really small. Okay, negative 3 cubed is negative 27, negative 27, and then I have x cubed. I'm just hitting my circle from the hole punch. All over y to the 2 times 3 is y to the 6. So this is my answer, even though I have a hole punch right there. Negative 27 x cubed all over y to the 6. Great. You have a lot of classwork, so my recommendation is that you try the classwork and come back and check your answers. And you can kind of do it one question at a time, or you can do it all at once and come back, and that way you can just double check the answers using the key in Schoology. And if you have specific questions, you can skip through to those specific questions. So you are working, pausing, and then coming back. All right, x to the 6 over x to the 2. My rule says that it's going to be x to the 6 minus 2, which is x to the 4. Number 2, I have 3m cubed over m cubed. I know anything divided by itself is 1, but also if I said m to the 3 minus 3, that would be m to the 0, which is 1. So 3 times 1 is going to be 3. I have 4m to the 5th n squared all over 8m to the 7th n. So here I'm going to use my strategy where I have the bigger exponent. I'm going to take the difference of the exponents and put the answer in the location where I had the bigger exponent. All right, so first I'm going to say 4 divided by 8 is, I'm going to leave 2 in the denominator, right? Because 4 goes into 4 one time, 4 goes into 8 2 times. M to the 5th over m to the 7th. I see that my difference is 7 minus 5, the difference is 2, and my bigger exponent was in the denominator, so I'm going to say that's m to the 5th down there. I have n squared here over n, that's going to be n to the 2 minus 1, so that's n to the 1. So that is my answer. And of course, always double check, and if you think you got the right answer and you think I got the wrong answer, then certainly send me an email or come by and see me. You might earn a Jolly Rancher out of it. All right, for these, I think my approach to this is going to make everybody have a positive exponent. It's just going to make things a little smoother, I think. So I'm going to keep 3 in my numerator, and I'm going to move a to the negative 1 down to the denominator, so it becomes a to the 1. B cubed is going to stay in the numerator, and c to the 4th is going to stay in the numerator. I've taken everything that was in the numerator and made it have a positive exponent. Okay, in the denominator I have 3 to the negative 2. I'm going to move that to the numerator, so now that's 3 squared times 3 squared up there. A squared gets to stay down here, and b to the 5th gets to stay down here. But c to the negative 1, I'm going to move it up to the top as c to the 1. Okay, now I just have a lot of positive exponents, and it's going to make things a little bit easier. All right, so I also think I'm going to simplify some things. So everything I can do in the numerator, I'm going to go ahead and do in the numerator. Everything I can do in the denominator, I will do there too. So I have 3 times b cubed times c to the 4th times 3 squared times c. I can multiply 3 times 3 squared, right? Because that's multiplying 3 times 9. So 3 times 9 is 27. I've taken care of my 3 and my 3 squared, which became 9. B cubed, I'm going to keep it as b cubed. It's done. C to the 4th times c to the 1 is going to be c to the 4 plus 1, that's c to the 5th. Okay, I've taken care of my numerator. I've kind of simplified it a lot. My denominator, I have a times a squared, so that's going to be, keep the base a, add 1 plus 2, it's a to the 3rd times b to the 5th. I'm getting there. I'm nearly done, and I'm going to stop having such a long line there, and we're going to say that this is 27, doesn't change. I have b cubed over b to the 5th. Okay, so I'm going to say b cubed over b to the 5th. The difference is 2. 5 minus 3 is 2, but b to the 5th was the bigger one, and it was in the denominator, so that's going to be b squared. Okay, I've taken care of my 27, and I've taken care of my b's. I also have c to the 5th that's going to stay right where it is. Take care of that. And I still have to make sure I don't lose my a cubed. A cubed stays in the denominator, so that should be my answer there. And again, there are several different ways that you could do this. So I'm happy to go over a different way if you want to talk about a different way. Okay, this is really scientific notation. So I'm going to keep this as scientific notation. So I'm going to say that this is 72 divided by 8, which I hope is 9, times, I'm going to keep my base. My base is 10, times 10 to the 3 minus 7 is negative 4. Since it came to me in scientific notation, I'm going to keep my answer as scientific notation, which is kind of the only time I'll let you use a negative exponent. Okay. We are moving on to number 6. Again, scientific notation. So I'm going to say that I have 4 divided by 2 is 2, times 10 to the 6 minus 8 is negative 2. Okay, I double check and make sure my first factor is between 1 and 10, and it is. Right here, how many places are you going to distribute this outer 3? It's 3 places. It goes to the 4, it goes to the 2, it goes to the y. So rewriting, we have 4 cubed over 2 cubed, y cubed. So that equals 4 times 4 is 16, times 4 again is 64. Over 2 cubed is 8, y cubed. Keep that in the denominator because that's where it was, right? My line was a little short. And so 64 divided by 8 is 8 over y cubed. Should be my final answer. All right, again, if I have a negative exponent and I have a fraction inside this parentheses, I can flip it upside down right now and get a positive exponent outside, or I'm just going to distribute that negative 3 to the 2, to the x, to the y squared. So I now have 2 to the negative 3, x to the negative 3, all over y to the negative 6. And so when I simplify that out, I'm going to have y to the positive 6, right? He moved up. And I'm going to put 2 to the 3rd in the denominator and x to the 3rd in the denominator. And of course, that's y to the 6th all over 8x cubed. Okay, nearly done here. So, oh my goodness, I'm going to simplify what I can inside those parentheses first. But I promise if you're super diligent and you're careful and you get that 3 distributed to everything inside the parentheses, if you didn't simplify first and you simplified at the very end, you will get the same answer. I'm going to simplify though. 2 over 4, I know I have, this is 1, this is 2, so I'm going to have 2 in the denominator. M to the 4th over m squared, 4 minus 2 is 2. And my bigger exponent was in the numerator, so I'm keeping the answer in the numerator. I have n squared over n, 2 minus 1 is 1, and n squared was the bigger exponent. So that's my inside information. This is all to the 3rd power. So let's distribute our 3 to everybody. So I now have m to the 2 times 3 is 6, n to the invisible 1 times 3 is 3, and 2 to the 3rd I can rewrite as m to the 6th n to the 3 all over 8. All right, finally, I have to take care of the outer exponent first for each of these, and then I get to multiply in my numerator. So let's get that going. I have 3 squared. I'm going to go ahead and write that as 9 because that one's easy. 3 squared times m to the 2 times 2, which is 4, times, got to get that to everybody. Remember, this -4 is inside parentheses. If I didn't have the variable at all, that -4 would be inside parentheses. So it becomes -4 times -4, or positive 16. So I'm going to have times 16. And then n to the 5 times 2 is n to the 10, all over 8m cubed, n to the 4th. I'm super lazy, so I'm going to say 8 goes into 8 one time, and 8 goes into 16 two times, canceling out where I can. Okay, so I know I have 9 times 2 is 18. M to the 4th over m to the 3rd gives me just m to the 1. 4 minus 3 is 1, and I stay in the numerator. N to the 10th over n to the 4th is n to the 10 minus 4, so it's n to the 6. Okay. You have homework in math space. It's probably linked in Schoology. Thanks for watching.